Okay, this is number 3 from our mole ratio lecture. And just like with 1 and 2, we're going to use the BCA chart, and we're going to fill in, and notice this is already balanced, so we're going to fill in the information we already know. And it says here how many moles of water will be produced if 0.45 moles of oxygen reacts. Okay, so we got to put this 0.45 somewhere on our chart, and it's talking about oxygen, so that's this one right here. Okay, it's not these. These guys have oxygen in them, but they're not, the substance isn't called oxygen. This is called carbon dioxide, this is called water. Okay, so we're going to put the 0.45 moles here. And it does not mention how much of this stuff we have, so we're going to assume we have plenty. We have it in excess, so we put the XS there. And we don't have any product to begin with. It hasn't been made yet, so we put zeros there. Okay, and then it also says that we're going to react all of this. So we're going to put a minus 0.45 there, and that means we're going to end up with none. We're going to use all that up. We're going to end up with none. All right, and then now we need to figure out the rest of this using the coefficients. Okay, this time it's not as easy to do these in our head, so I'm going to show you how to use the mole ratio calculation method. So let us begin. All right, so we're always going to start with what we have. So we're going to put 0.45 moles of O2. And then we're going to use our mole ratio, which will be a fraction, and the numbers from the fraction are going to come from the coefficients. All right, so let's solve for this one first. So we want this, right? We want this, and this is what we have. So our ratio is going to be want over have. It's going to be want over have, 2 over 15. So I'm going to put my 2 there, and just so I can keep track, I'm going to label it. And 15 over here, label it. Okay, and then you can see here that this is going to cancel that. So my answer, after I do my calculation, the units of my answer are going to be moles of C6H6. Oops. Okay, so I'm going to take my calculator, do the math, okay, which is 0.45 times 2 divided by 15, and I get 0.06 moles of C6H6. So I'm going to go ahead and put that there. Okay, and then I'm going to do the other one. So I'm going to again start with what I have. Fraction, it's going to be want over have. Okay, so I'm going to put 12 CO2, and what I had was O2. There's my, oops, sorry, want over have, that's my have. 15 O2. Okay, the O2 cancels. Do the math. 0.45 times 12 divided by 15, and I get 0.36 moles of CO2. 0.36. Okay, and then I'm going to do next one. And this time, this is the thing that I want, right? This was the thing that I had. Now you can change, you can do want over have, because now you have this one, right? So it could be 6 over 12, but you're going to have to start with this amount, 0.36 moles of CO2. But let's just keep it consistent here. So I want water, so 6H2O, and I have O2, so it's 15. Do the calculations. 0.45 times 6 divided by 15, and I get 0.18 moles of H2O. Write it up here, 0.18. And you can see 6 is half of 12, right? So 18 is half of 36. So it works out. Even if I did it this way, you could see how it would have worked out anyway if you had started with this amount instead and done the 6 over 12 as your mole ratio. Okay, let's finish this out. So we didn't know how much of this we had. We used up this amount because it's a reactant, and because we didn't know how much we started with, we know it was more than enough, so we're going to have extra of this, excess of this. Okay, over here we made this, so this is going to be a positive. We started out with 0, we made that, so that's what we're going to end up with, and same thing here, 0.18. Okay, and then they were asking for how many moles of water will be produced, and here it is. That's how much was produced with this starting amount. Okay, so let's take a look. So this is the BCA chart method. We did a lot more work, we got a lot more answers than the question was asking for, but you have a better picture of what's going on. You have these reactants that are being used up, okay, and you have these products that are being made. Okay, in future lessons, you're going to have different starting amounts, and you got to figure out, okay, which one's going to be used up, and this is going to help you to do those more complicated ones. And it's super, if you get this down, then those harder, what other people say are harder problems, they're going to be easier for you. Okay, let's look at this. Okay, I want you to, this is the traditional way of doing stoichiometry. And what I want you to notice is there's a pattern. Okay, so you're going to start with what is given. Start with a given. This is going to be given in the problem. Okay, and then this is your mole ratio. And it's going to be want over have. This is what you need to remember. Okay, and then this want over have comes from the coefficient, right? So this right here, that's your mole ratio. Okay. And then, you want to label things so that you can keep track of what number goes with what part of the equation, what substance. Okay, keep track, write those formulas in there. Believe me, it's going to help you in the end. Okay, and that is it. So you can just, if you have this done, you can attach it in your notebook, maybe on page 78. You can put it there if you want, if you're keeping your notebook up to date. By the way, I'm not going to be collecting your notebook, so that's just for you. If you plan on going into science or medical field or anything like that, I've had past students show me their old notebooks. They said it helped them. Okay, well, refer back to this video if you get stuck with future problems. Don't forget that I have office hours where I can give you one-on-one real-time help just like this over Google Meet. And you can always email me too. Okay, guys? All right. See you later. Have a good day.